Hi, this video is about the chain rule, and chain rule is actually used when we have compositions of two or more functions. So let's say we have two functions f and g, which are both differentiable. Then the derivative of f composition g is equal to f prime times f prime of g times g prime. Or actually, if we put u equals g of x and then y equals f of u, then this is the chain rule. Y prime, which is dy over dx, is equal to dy over du times du over dx. So that means derivative of f of u, but y is f of u. So derivative of f of u with respect to u times derivative of u with respect is equal to derivative of g of x with respect to x. So f of u derivative of f of u with respect to u is going to be f prime of u, and derivative of g with respect to x will be g prime of x. But remember, u is g of x, so we have f prime of g of x times g prime. So using the chain rule, actually, so the proof is actually a little bit detailed, so I'm going to skip the proof of chain rule. But we need to know the chain rule because it's going to be a technique used for differentiating so many functions. And the point of chain rule is, we break a function which is not a simple power function or an exponential function or a trigonometric function, but more a composition of those two or three functions. We break them into pieces so we can differentiate easily. That's like where the chain rule comes into help. So here are some examples. E to the x plus 4x to the power 10. So here we call u like e to the x plus 4x, and then we call the whole thing y. So we call the whole function usually with y, and then the first function that happens to input x, like e to the x plus 4x, is the first thing that happens to x. So we call that first part u, and then we call the remaining, the whole part, y. That's usually how it goes. So if there is like the first function, we make a substitution u, and then the second function is here taking the 10 power, we make a substitution for that. If there are some other functions applied, then we keep making substitutions and then use a chain. So let's say if we have u equals e to the x plus 4x and y equals u to the 10, then we write the chain rule, dy over du times du over dx. So y is u to the 10. So u to the 10 over u to the 10 with respect to u, and u with respect to x, e to the x plus 4x with respect to x. So u to the 10 is a power function. It's going to be 10 u to the 9, and the other function will have the derivative e to the x plus 4. Then we put u back, which is e to the x plus 4x, and we get the result. Second example, let's say e to the tangent x, derivative of e to the tangent x. So the first function which happens to x is the tangent. The tangent of the input is taken, so that's u. And then the second function that happens is writing this tangent x as a power on e, exponential function e. So that's y. Now, if you write the chain rule, y with respect to u times u with respect to x, so e to the u with respect to u, which is e to the u. Tangent with x with respect to x is secant square. So we put u equals tangent x back, e to the tangent x times secant square is the result. And the third problem, let's say we have sine of 2 to the x plus x squared. Well, the first function that happens to x here, the input is 2 to the x plus x squared. So that's u. Then the second function is sine. So we call that y. And then we write the chain rule, y with respect to u with respect to x. So sine of u with respect to u will be cosine of u, and 2 to the x plus x squared with respect to x will be 2 to the x times ln 2 plus 2x. And then we put u back and we get the result. Another example, let's say cubic root of x squared minus 7x plus 5. Well, the first function that takes x is x squared minus 7x plus 5 with the polynomial, call it u. And then the second function is taking the cubic root of this polynomial, so call it y. U is the polynomial, y is the cubic root. Then write the chain rule, y with respect to u, which is u to the 1/3 with respect to u is equal to 1/3 times u to the minus 2/3. And the polynomial with respect to x is 2x minus 7. And then put u back, which was the polynomial at the beginning. That's the result. And then another example, let's say secant of e to the x plus cotangent, derivative of this function. Now, the first function is e to the x plus cotangent, so call it u. The second function, which happens to this e to the x plus cotangent, is taking the secant, so call it y. Then write the chain rule, y with respect to u times u with respect to x. So y with respect to u is secant of u with respect to u, which is secant u times tangent u. And u with respect to x is e to the x minus cosecant square x. Remember, the derivative of cotangent is minus cosecant square x. And then put u back, and we have the result. Another example, let's say 5 to the x cubed plus 2 sine x. Here, the first function that takes x is the x cubed plus 2 sine x, call it u. And then the second function is writing this function as a power of 5 to the exponential function 5 to the x. So call it y. So u is x cubed plus 2 sine x, y is 5 to the u. Then write the chain rule, y with respect to u is 5 to the u with respect to u, which is 5 to the u times ln of 5. And then take the derivative of the u term with respect to x, that's 3x squared plus 2 cosine x. And then put u back, which I forgot to write, but you just write 5 to the x cubed plus 2 sine x times ln of 5 times the polynomial, okay? Now, there are some, we actually have three types of chain rules. Like one of them is the chain rule for the power functions. So if we have y equals f of x, and if it's the base of a power function, instead of x to the n, if we have f of x to the n, then its derivative is, we take first the power function's derivative. So n times f to the n minus 1 power times now the derivative of the base, f prime. Or if we have, let's say, y to the n prime, then that's going to be y times y to the n minus 1 times y prime. If we have an exponential function, but the power is another function, then the derivative is, we have just seen it in the examples, it's going to be e to the function e to the f of x times derivative of the power, so f prime. Okay, so the exponential function comes back, and the contribution is the derivative of the power. So if we have e to the y, for instance, then its derivative will be e to the y again times y prime. Here, y is a function of x. We know y is f of x. For trigonometric functions, like we can have 6 versions, but all of are same. Once you remember the derivative of sine, tangent, secant, cotangent, cosine, cosecant, they all go the same way. So derivative of sine of f, that's going to be, first we take the derivative of the trigonometric function. So that's going to be cosine. We don't do anything with f, we just write it in cosine f times, then we take the derivative of f, f prime. Derivative of tangent f is secant square f times f prime. Secant f prime is secant f times tangent f, which is the derivative of secant. Then we multiply by the derivative of f, which is f prime. Well, it goes same for the derivative of cosine f, cotangent f, and cosecant f also.